Welcome to this first video for sections 3.6 and 3.7. In this video, we're going to be looking at the area between curves and how we can apply this in various situations. So we're going to start with a short video that kind of gives us the general abstract idea, and then we'll move to some examples. So our basic premise here is that if you have one function f that is greater than another function g, in other words, f is above g, the graph of f is above g, on some interval from a to b, then the area between the two curves is given by this integral. We take the integral of the function f minus the function g, and that will give us the area between those two curves. Now, we'll go to Desmos here in a moment, but a couple of notes. You're typically going to need a graph to see which one is above and which one is below, which one's the upper function, f of x, and which one is the lower function. So it's very difficult just to rely on our intuition to determine which one is greater and which one is smaller. The second note is that you're going to also need to know where the graphs intersect so that you can find the limits of integration. So let's take a look at an example in Desmos so you can see what we mean. So here we have two functions. The red function, let me put this into projector mode so it's a little bit easier to see. So the first function we're looking at here is f of x is equal to negative x squared plus 8, and that's in red. So that's this function here. The second function is g of x equals x squared, which is in blue, and it's this function right here. Now, what you'll notice is that from this point right here, when x is negative 2, until when x is positive 2, f of x is above or greater than g of x. So if we wanted to find the area between f and g in this interval from negative 2 to positive 2, we can use what we saw in this slide over here that says, let's just take the integral of f of x minus g of x. Now, to see what's going on and why we're subtracting, let's go back to the graph here for a moment and take a look. Let's just pretend that we are only taking the integral from negative 2 to positive 2 of the area underneath just f. Let's ignore g for a moment. So let's turn g off for a second. And then let's just take a look at what happens when we just find the area underneath the red curve. So I'm going to display that this way. It looks something like this. Okay, now, obviously, that is just the area under f. If I turn g on, you can see that there's some area underneath here that we don't want to count, here on the right side and over here on the left side. So if I were to show that area, it's going to look like this. So there's the area under G. It's this bluish area here. And so what we're really wanting is the area between F and G, between negative 2 and positive 2. And you can see that that is that now pure pinkish color here. We want to omit the area that's in blue. So the way we can do this, let's turn off F now. If we take, let me also do this for us so we can see this. So if we take just the area that's in blue and we subtract that from the total area that's in this reddish pink color, right? And keep in mind, that includes what's underneath G right now. But if we take this area that's in pink and then we subtract off this area in blue, what remains is the area between the curves which is this pure pink color. And so going back to our slide here, that's why we take the integral of one function minus the other, because taking the integral of f will capture all of the area underneath f and potentially underneath g, but then we have to then just subtract off the area under g to get what is left over in between the two curves. So that's the basic idea for finding the area between curves. Identify the greater function, the lesser function, identify the limits of integration, and then take the integral of f minus g. And the limits of integration are going to be the points where those two graphs intersect. Right? It doesn't make sense to take the integral from -4 to +4 because that's not going to adequately represent the area between those two curves. So we need to know where the two graphs intersect so that we can find the limits of integration. And in this case, you can see here, I've made that happen between -2 and +2. So if I were to, let's say, let's add an expression here. So now let's take the integral from -2 up to +2 of the function f of x minus g of x dx. This area here, 21.333, is the area of this pink region that sort of looks like an egg. So that's the idea, and now we'll move to some examples.